Okay, so, yes. No, sir, I'm sorry, we're started. Yeah, sorry. So let's see here. We're going to go ahead and start the focus activity, but you'll notice it is numbered 4 because I usually like to have a couple of different sets. Let's see, is it rational functions? Let's see here. Nope, that's the extra credit assignment that you're getting. That's Monday. You want to look at Tuesday. So here's Tuesday. These are the notes, sir. There you go. Okay. So this is numbered 4 because usually within a grading period I'll have 2 different sets. Gives you a couple of opportunities to have a really good quiz grade. All you're doing is just working them with me, keeping up with them, turning them in. So we'll probably go ahead and get this next set. Definitely 4, 5, 6. Maybe we'll get to 7. We'll kind of see. But when you're already thinking about it, I mean, 2 weeks from this Friday is already the end of the first 6 weeks. So it's going to be going pretty quick. I mean, tomorrow you're getting your progress reports for the first time. In 7th period, you'll be taking those home. But just a couple of housekeeping items in class. Let's see. Tomorrow, as of right now, we have that quiz. Okay, and I may decide to go ahead and push that back to Tuesday. We'll kind of see how far we get today. If we have the majority of the lesson done, I would say we'll go ahead and keep it. If not, we'll see what happens. On Monday, the 17th, so a week from this coming Monday is when you'll have your second exam. We'll want to look for that to have the rational functions that we've been talking about on here. It'll also have compositions of functions, possibly inverses. Again, it depends on how far we're able to get next week. And we'll just kind of see how that plays out. And don't forget, Friday, what's going to be happening? Okay, Jalen, I'm not going to be here. I'm going to be at a workshop, so I'm leaving with the substitute, an assignment for you guys to look at. That'll be due on Tuesday when we get back. And Tuesday morning is the deadline if anybody wants to retake exam 1. All right. So let's get to it. So this focus activity number 4 does allow us to go back and kind of refresh ourselves on sets, intersections, unions, all that good stuff. So it says a squash club has 27 members. 19 have black hair, 14 have brown eyes, and 11 have both black hair and brown eyes. Place this information on a Venn diagram. Okay, so let's say this rectangle is my universe, and this time I'll even go ahead, put 27 in the corner, because there's 27 people in the sample. Now, we know there are some people that have both black and brown eyes. Well, black hair, I should say, and brown eyes. So I'm going to have overlapping circles here. Let's say BL represents those who have black hair. BR will represent those who have brown eyes. Okay, so I've got the framework done. Would anybody like to come on up and show me where I put my values for the Venn diagram? Brandon, you got it? Okay. Okay. Either Brandon, whoever wants to come on up. Thanks, sir.
It's black hair.
Yes, so that's black hair. Now we're very close. You're not actually, the one you erased is the one you were correct with. So I think we know that there's 11 people who have both black hair and brown eyes, right? But how many people have black hair total? 19. So how many people should have black hair but not brown eyes? 8. So what should I put in place of the 19?
Oh, 8.
There you go. Because see, the circle that's labeled BL for black hair, there has to be a total of 19, but we're putting the numbers in specific locations. We know that 11 have both. Now only 8 people have black hair because there's 19 total. And there is one more we want to go ahead and change. There's 14 people total who have brown eyes, but we've already gotten 11 of them. So 3 people should have brown eyes, but not what? But not black hair. And is there anything we're missing from the universe? There you go. If you add this up, 8 plus 11 plus 3 only gives me 22 people. But I know there's 27. So there's 5 people who belong to the universe who don't have brown eyes or don't have brown hair, or black hair, I should say. Keep on sitting. So somewhere out there, and it doesn't have to be, at the top, as long as it's within the rectangle outside those circles, we got those 5 people. Okay, so there's A. That's taken care of. Okay. Now, B1. Hence, find the number of members with black hair or brown eyes. Black hair or brown eyes. So think about sets, what we talked about a couple of weeks ago. What does that word or mean to you? Is it intersection or union? Union. There we go. Or is union. What word is related to intersection? And. There we go. So I want to take this sentence and I just want to rewrite it as a mathematical expression. So I'm going to say black hair, okay, the set black hair, or brown eyes. Now I'm just going to go ahead and throw this out there. Is anybody in here IB? Nobody's a part of IB? Okay. My other classes I do. I just wanted to make sure. But you might see this occasionally. I'm just going to go ahead and mention it. If you have an expression where there's a little n outside of it, that's just asking you for the specific number of items in that set, which is what we would do anyway. I just kind of want to show you the notation. So what does the union mean? Is that the intersection, or is that the union, or is it the marriage? So do I want to combine everything, or am I just looking for the overlap? I want to combine everything. So I will take the 8, 11, and 3. So how many people have black hair or brown eyes? 22. So or is the key word here. They don't have to have both. They can have one or the other, or both. Okay. Now the other one, black hair, but not brown eyes. So I'm going to say black hair. Now, but not brown eyes. So this one's an intersection. But how would I show not brown eyes? What are we talking about? Does anybody remember? Okay. Nathaniel's absolutely right. We're talking about that little tick mark, right? What does that mean when we're talking about sets? That's the what? The complement. There we go. What in the world is a complement? It's the opposite. So it doesn't include what? There you go. We're talking about everything in the universe except the number of people who have brown eyes. Everything outside of that set. Does anybody think they know what it would be? It would be 8. That's exactly right. Now, the one thing that people have been asking me all day, well, if the complement for brown eyes is everything outside the set, wouldn't we have to look at those 5 people as well? Now, they would be included in the complement, but what if I did it like this? Maybe this will help some folks kind of see it visually. Let's say I go ahead and recreate the Venn diagram a couple of times. You know, this is still the number of people with black hair, brown eyes, black hair, brown eyes. Okay. But let's say this one, I just want to see every person who has black hair. Well, that means I would just shade this entire circle, right? Okay. But now over here, I'd want the complement of everyone with brown eyes. What would I be shading? Yeah, it'd be everything but the circle for brown eyes. So I'd be shading everything outside here. Look just like this. Okay. Now remember, I'm looking for the intersection. So is that the combination, or is that just the overlap, what they share? Yeah, the overlap. So imagine if I could take one graph and put it right on top of the other, there's only one region where they would both be shaded. Okay, and it's this area right here that's going to look kind of like a crescent moon. And that's where we got our 8 from. Okay. Everybody okay with that? Questions? Okay. All right, well, good. Go ahead and put that someplace safe. We're starting the set over again in a folder, a binder, whatever you need. And probably in a couple weeks, I'll be asking you for those. All right. Good. Okay. All right. Now, first thing we need to go ahead and do, I'm going to correct a horrible mistake I made yesterday, and I do apologize for it. I don't know what I was thinking. Okay. I'm going to go ahead and go through the synthetic division again. Okay, it's only going to take a second, and actually this time I do know what I'm doing. Okay, so I'm going to take x minus 2, and I want to divide it into x squared minus 5x plus 4. Okay, so the framework is the same. I was correct about that. You have a box in the top left. You have a line. If you're above the line, you add. If you're below, you're going to multiply. Okay, there's just one mistake I made when I began the process, and I'll tell you what it is. Well, can anybody tell me what's going to go in this box right here? 2. It's the value of x that would make that denominator 0. Because 2 minus 2 is 0, so I'm going to put the 2 right there. Now, your coefficients and your constant, okay, the 1, the negative 5, and the 4, those are going to follow to the right. So the 1, negative 5, and 4, just like that. Okay. Remember, you always want your dividend, what you're dividing into, to be in standard form. So you want it to start with your largest power and then get smaller as far as the powers go. Okay. Well, here's the mistake I made yesterday. I dropped the 2, which was really dumb. I should have dropped the 1. The first number outside the box is what drops. Okay. Everything else was correct. I just dropped the wrong number, so I do apologize about that. So now, what's 1 times 2? 2, I put that in the very next column, and now I add. Negative 5 plus 2? Negative 3, I'm going to put that right below. Okay, now I do it one more time. Negative 3 times 2? Negative 6, and then plus 4, negative 2. There you go. So this last value is going to be my remainder. Now, typically, you would go ahead and take that, put it over your divisor. So you could say minus 2 over x minus 2. But here, I'm not really concerned with the remainder. I'm only interested in that slant asymptote, the oblique asymptote. Okay? So your answer will always start 1 degree less. So this guy started x squared. Mine's going to start with an x. But after x, you just have your constant. Okay, so my slant asymptote is simply 1x minus 3. Okay, so y equals 1x minus 3. That would be the slant asymptote for that function I gave you. Okay, and again, I do apologize. That was my mistake. I don't even know what happened yesterday. It was a Monday, Tuesday. That's all I can say. All right, so are we good on that? Okay, we'll get the opportunity to practice that again, and I'll set you on the right track because hopefully I didn't mess anybody up too bad. And I think we had just started this one, right? Yeah, I don't think we got very far. We did talk about 3 cases, so we have the horizontal taken care of. In fact, let me go back over here real quick. Remember, these are my 3 cases, and we're looking at the degrees to determine if there's a slant or if there's a horizontal. Remember, degree is just the largest power. If the degrees are the same, which is typically what's going to happen for us, you divide the leading coefficients. Okay, just like we talked yesterday. If the numerator's degree is smaller, okay, this is where it's y equals 0, immediately the x-axis. You don't have to do any work. Okay, now where you might have to do a little bit of algebra, what we just did is if the numerator's degree is larger than the denominator's. If that's the case, then you'll go ahead and use synthetic division. Okay, does anybody in here remember long division? You may or may not. If you do remember that and you prefer that, whatever, as long as you're able to get your slant asymptote, that's all I'm interested in. Does anybody want me to go through the long division, or do we just want to stick with the synthetic? Let's stick with the synthetic then. I think a lot of people are good on that. Okay, so we're still looking at these to go ahead and graph. Let's see, we went ahead and foiled those together. So x minus 2 times x plus 3 gave me this. Now, the reason we have the horizontal asymptote at y equals 0, the x-axis, is because the denominator's degree is larger than the numerators. And I think this is where we stopped yesterday. I was saying, what is anything to the 0 power? 1. So it's just like 2 times 1, so it's still 2. But you can at least still see it with a power. Okay. So let's go ahead and take a look at what else we have. Let's go ahead and start with our intercepts here. Okay. Now for the x-intercepts, there's going to be a really nice way to do this. And I'm going to go ahead and give you all the shortcuts. I wish I could move that over. I'll just go ahead and do this. 2, if this thing will write. 2 x to the 0. And what was that? X squared plus x minus 6? Okay, so I have a little bit of room. So for the x-intercepts, set the numerator equal to 0. And I'm going to abbreviate this so I have enough room here. So set the numerator equal to 0. Any values of x that make the numerator 0, those are going to be your x-intercepts. Okay. Well, you'll notice here, is there any value of x on the numerator? No. So if there's nothing to set equal to 0, well, what would that tell you about the graph? He doesn't cross the x-axis, and that very well could happen. So if we don't have anything of an item, we'll just say none. Okay. So there is no x-intercept. Okay. All right. Now the y-intercept, all we want to do is replace x with what? Brandon? Think about if you're anywhere on the y-axis, like what's this point right here? 0, 5. What's this point right here? 0, negative 2. Everywhere on the y-axis, x is always 0. So simply replace x with 0. Okay. So replace x with, and that's our abbreviation for with, 0. Okay, replace x with 0. Now you can either do this in the original problem or you can go back to the factored version. It really doesn't matter. So let's see. I have 2 over, that would be 0 minus 2 times 0 plus 3. So all I'm doing is replacing x with 0. I want to find the y-intercept. Okay, well 0 minus 2. That's a negative 2 times 0 plus 3. 3, so it looks like I have a 2 over what? Negative 6. And does that reduce at all? Okay, so negative 1/3. There you go. But if we do have intercepts, let's go ahead and write them as an ordered pair because they're a location. So everybody okay where I got the negative 1/3? So this would be 0, negative 1/3. Okay. That's it. Now, let's talk about your vertical asymptotes. Okay. These are very easy to find. Okay. Set the denominator equal to 0. So I'm going to write my little hint here. Set the denominator equal to 0. Any value of x that makes the denominator 0 is going to be a vertical asymptote. Okay. Now here you'll notice they've already got it factored for us, right? And it's always a good idea to factor it if possible. So I'm going to take x minus 2, x plus 3, and I'm going to set it equal to 0. Okay. Now do you guys remember the property we talked about? I want to say it was yesterday. The zero product property. So if I've got two groups that I'm multiplying equal to 0, well, what do I do? What do you guys think? Angel? There you go. Set them each equal to 0 individually. So x minus 2 would equal 0, or x plus 3 is equal to 0. And now we just go ahead and solve. So here I would have to add 2. So x equals 2. That's a vertical asymptote. For the other one, I'd have to what? Subtract the 3, get rid of him. X equals negative 3. So he's another vertical asymptote. Okay. Now, will every rational function always have 2? No, it could have 1, could have 2, could have 3. It's very possible it may not have any vertical asymptotes. Okay. So for my vertical asymptotes, I want to write those equations. We have one at x equals 2 and x equals negative 3. Okay. Now, we're going over a lot of information. Is there anybody who's not sure where anything is coming from? Okay. How do I look for x-intercepts? Set the numerator equal to 0. Solve for x. Okay. How do I find the y-intercept? Replace x with 0. How do I find my vertical asymptotes? Set the denominator equal to 0. It's always the same for every different function. These rules don't change. Okay. And then if you're looking for the horizontal, which we already have, look at your degrees, those three cases. Right, Nathaniel? Right. Okay. Now, does anybody know what it's referring to when it says whole? Yeah, like if you ever have a graph, maybe a branch or something, but there's a hole in it, like an ordered pair that's been removed. It's been plucked from the branch. Okay, I'll go ahead and tell you this one, and I want you guys to tell me how we're going to know, but you have to see another example first. So I'll tell you for this example, there is no hole. Okay, no hole. There will be no hole. Now, the domain and range, let's go ahead and wait until we actually have the graph. Okay. So are there any questions on how I got this information? Okay. So let's take it and let's start to get a picture of what this guy looks like. I always start with my asymptotes. Okay. We had two vertical, one at a positive 2, so one right here. And then we also had one at a negative 3. Okay, so x equals negative 3, x equals 2, and we always want to label. Right, Rhett? Yep. Right. Okay. Now, where was my horizontal? It was y equals 0. But here's the thing about horizontal and slant asymptotes. You won't be drawing the middle, and there's a reason why. Now, if you want to go ahead and draw the horizontal asymptote all the way through, I'm not going to count off, but let me ask you a question. Do these graphs ever touch the asymptote? No, they're going to get as close as they can, but never touch. Occasionally, you're going to have graphs that might look something like that, or in some way is going to look like it crosses your horizontal asymptote. This is where the math starts to get a little abstract, okay? But you just have to realize that around the origin, the asymptote doesn't exist yet. It hasn't started to form. So it's perfectly fine for that to happen. So that's why I don't draw the middle of them. Okay, like I said, if you want to go ahead and draw the middle, please feel free to do so. Just, don't be surprised if one of your graphs crosses that asymptote. Okay. Now let's see. We had a y-intercept at negative 1/3. Okay, so just below the origin, maybe right here. Okay. Now, what we want to do is try to figure out where the graph is with respect to everything we have, because all the information I have is right here, right? For example, to the right of 2, this vertical line right here, I'm either going to have a branch that's curving above or that's curving below. And the question is, how am I going to know what it is? Okay. This is where you're going to use what's called a sign chart. Very, very simple to create. Okay. But all we're looking for is a positive or a negative. All right, so let me show you what I mean. I'm going to create a number line. Now, this number line right here is your x-axis. Okay. Any zeros or values that make the denominator 0, you want to put on your sign chart. So I've only got 2 vertical asymptotes, right? So I'm going to go ahead and put negative 3, and I'm going to go ahead and put the positive 2. It never touches the x-axis, so I don't have to put any other values. Okay. Now, what we want to do, you see how you've got 3 regions created by the vertical asymptotes? Well, it's the same thing here. You've got 1, 2, 3. All we want to do is pick a number that's in the region, and we're going to go ahead and plug it in. So we're going to hope to get either a positive or a negative. If we get a positive, that tells me the graph is above the x-axis. So what do you think is going to happen if we get a negative? It's got to be below. It's just our way of kind of analyzing and figuring out what's going on. Now, here's the beauty part. You can choose any number that you want. Okay. For example, give me something bigger than 2. 37. I just like that number so much, let's go for it. But would 5 work? I mean, would 3 work? Yeah, as long as you don't choose 2 itself, because we know what happens there. It's an asymptote. So let's choose 37. Okay. As long as it's on that interval. Now, I always personally go with the factored version, but you can always plug it back into the original if you want. Now up top, see, we don't have an x, right? But that 2 is positive. So I've got a positive number up top, and I've got 2 groups down below. So if I plug 37 in here, what's 37 minus 2? 35. But again, we call it a sign chart. See, because we're only interested in the pluses or the minuses. We don't care about the number itself. So that 35 is definitely positive, right? So you see how I'm using the problem to mimic what I've got? Now plug in 37 for the other one. What's 37 plus 3? Okay, which is a positive number. So what's a positive divided by a positive? So I know that whole region is positive. So where should I put my curve? He would have to go above. So I know my curve would have to go here. That's all there is to it. Choose a value and go ahead and plug in. Okay. Let's try it to the left of -3. Let me go ahead and erase this. All right. So I just need a value smaller than -3. -4. Perfect. Okay. I was actually wondering if someone was going to say -37 again. Were you thinking about it? Okay. But could you use -37? Yeah, you could if you want. I've got a student in 8th period who always wants to use a million, whether it's positive or negative. It'll work. I don't know if you want to go with a number that big. Okay. So let's try it again. So we have -4. Okay. So I'm going to go ahead. We've got a 2 on top that's already positive. And then we've got the 2 groups down below that we have to look at. So if I plug in -4 in here, what's -4 minus 2? So -6. So that's a negative number. Okay. What is -4 plus 3? That's another negative. Now, a negative times a negative is what? A positive. And what's a positive over a positive? So where should I put my branch for this last region? It should be above. So he's going to curve like this. Okay. Now, can anybody guess what the middle is going to be? Should it be positive or negative? A lot of people are saying negative. Why couldn't it possibly be positive? Now, because think about it. If this guy were to open up like that, okay, well, he would have to cross what? Wouldn't he have to cross the x-axis? But do we have any x-intercepts? No. So that tells me more than likely he has to do what? He would have to open down. But let's say, you didn't think about that. You're just thinking, okay, what number can I plug in? So somebody give me a number. 315. Okay, 1 would work. What'd you say? What'd you say? 15. Well, 15 would work, but it would be in this interval. So we'd need something between -3 and 2. So 1 would be perfect, 0 would be perfect. But let's go with the 1. That's the first one I heard. Okay. So now the 2 up top is positive. There's nothing to substitute into there. Okay. What about 1 minus 2? That's a negative number. 1 plus 3. That's a positive, right? See, all I'm doing is looking at the problem in terms of pluses and minuses. Is everybody okay how I'm doing that? Okay. Well, what's a negative times a positive? So this would be a positive over a negative, and this one is negative. So I know that this guy right here where it says -1/3, he would have to go down because the graphs are going to want to always get as close as they can to those asymptotes. Yes, sir? Oh, yeah. I mean, you're going to notice a lot of connections between these. The reason I bring up the sign chart is because if we were to fill this in completely, and I mean, there's more to the sign chart that I'm talking about here, but this is all we need. But you'll notice everything in the sign chart is telling you what's happening graphically. Okay. Now, let's actually see how well we did. Okay. Let's go ahead and plug this in. 2 divided by, and I'll actually go ahead and plug in the factored version. Okay, so let's come on over here. So control divide. So 2 over, what was it, x minus 2, x plus 3? X minus 2, and it's starting to do that, so I'm going to have to use my mouse. Okay, so parentheses, x minus 2, parentheses, it was x plus 3? Okay. Wait. Did I put in the wrong values? -2 and +3. Did I type in something wrong? Oh, I have that negative on the outside. I was about to say, oh, don't want to be making another mistake here. Good Lord. Okay. Tab. So let me go back up here. Let me get rid of this negative. Hooah. There's the graph we should be getting. And isn't that exactly what we did by hand? Yeah, that's it. That's all I want you to be able to do. Without the calculator, can we get a reasonable idea of what it looks like? Okay. Now, let me go ahead and show you. We've been working on this. Now that we have the graph, okay, let me go ahead and erase this. Okay. So domain and range. Now, the thing about these, they are always infinitely wide, no matter what. They will always go from negative to positive infinity. But are there any values of x that we had to throw out? -3 and 2. Any value of x that makes the denominator 0. So for my domain, I could easily say -infinity to -3, union what? -3, 2, because the graph exists between the two. -3 to 2, union 2 to infinity and beyond. Little Toy Story joke there. You know they're coming out with a part 4, right?
Yeah.
Seriously? You know, and I'm telling you what? I should have been a movie producer. Perhaps I missed my calling because I think I have the best plot line for Toy Story 4. Okay, here's my pitch. You know the toys are now with that little girl? Bonnie. Okay, that's her name, right. Andy decided to give them up before he went to college. Okay, well, here's what I think would be a great story. It'd be a tearjerker. So you already know that Bonnie's mom is friends with Andy's mom. So they communicate and they would know. I think Andy should become sick or get into an accident, something that puts him in the hospital, and the word gets to the toys that Andy is in trouble. So the story would be them making it there to see Andy and finally revealing themselves to him. How great would that be? I have no clue what they're going to do, but I think it would be awesome. Yes. Did you ever watch that YouTube channel, How It Should Have Ended? They did a How It Should Have Ended on Toy Story 3, and Andy's about to give the toys to the little girl, and he's like, no, I ain't doing that. And he gets in the car, and he's like, yeah. And all the toys jump out of the box, and they're like, yay, Andy, we love you. And he's like, what the? And he crashes the car. Have you seen that? It's hilarious. Okay.
Just so you know, someone on Tumblr already thought about that.
What I just said?
Yeah.
Okay, what was the date? Because I'm willing to say mine was first.
Like a year ago.
I've actually had this for a couple of years. Okay. All right.
They're thinking about for the new Toy Story, like Buzz Lightyear is like going to be like a default, like a faulty toy, and they're going to have to go and like fix him.
Really?
That's what they said. Like one of the ideas were.
I think my idea would be better, right?
Yeah.
How cool would that? I mean, that would be a tearjerker. And I'll admit, only one of the Toy Story movies actually got me teared up. It was the third one, when they were in the trash bin where they're about to be incinerated. I was really thinking, what are they going to do? Oh my God, Woody, what do you do? You know. And then the claw came up again. Okay. I saw the first one in the theater, and I've saw the rest of them on DVD and Blu-ray. So probably take my kids to it. They love that stuff.
Someone subscribe to your YouTube channel.
Oh, there you go. Well, that's where I post my videos now because SchoolTube crapped out on me. It just would not publish the videos anymore, so SchoolTube does it so much faster. And what?
Like, I remember freshman year you told us how, like, your kids would always play the games. Like, you would get your kids playing, like, that might play with them.
Oh, my son's really good at video games. He plays a lot of them. He's doing good in school. You know, I make sure that's good. Right now, he's currently on Minecraft.
Oh.
He's able to do some pretty amazing things in Minecraft, like especially with the redstone. Like, I'll be like, how'd you do that? Well, he's like, it's simple, Dad. I just put the comparator right here and blah, blah, blah. I'm like, whatever. Okay. It's a block game. Anyways. Let me go ahead and give you the range. Now, the range is the same thing. It's just the height. Okay. So there's only one y value that you have to remove. Just 0 because that's where your horizontal asymptote is. So negative infinity to 0, union 0 to infinity. Or for these like the domain, you could simply say all reals except x can't equal negative 3 or 2. You would just have to put on that little sentence at the end. Okay. All right. Now that one took a little longer because it was the first one, and this is why I had the idea at the beginning. I'm thinking, let's go ahead and not worry about that quiz tomorrow. We'll go ahead and probably do it on Tuesday of next week. That'll give us another day tomorrow to go ahead and work on this and get some practice on Friday. Now I do want to go ahead and show you this. Okay. Now take a look at this one, the very next one. It says 2x minus 1, x minus 2 over x minus 2. Why does this one have a hole, but the other one did not? That's exactly right. If when you factor, if there is any one term or any group that cancels, there's going to be a hole. Okay. Now, the group that cancels, I'm still going to set him equal to 0. So if x minus 2 is equal to 0, what does x equal? X equals 2. Now, the value of x that makes that canceled group 0, that's where the hole occurs. But remember, the hole is a location. If I have the x, I need the what? I need the y. Does anybody know how I would find it? That's exactly right. Anything that did not cancel, because if I plug 2 into x minus 2, we already know what's going to happen there. It becomes undefined. You can't divide by 0. Any group that did not cancel, you go ahead and plug it in there. So 2x minus 1, this would be 2 times 2 minus 1. What's that? 3. So I know for sure whatever this graph looks like at 2, 3, there's a hole there. Why will it not let me? There you go, 2, 3. That's what you're looking for. There has to be a common factor, a group factor that cancels if there's going to be a hole. Okay, so we'll pick up with this one tomorrow. Okay, we'll go from there. All right, so good job, guys. Thank you very much. You did a great job.